Good evening. Today we are going to deal with the linear motion, and we are going to look at several subtopics on linear motion and some of the terms that are used in linear motion. So we have linear motion as our today's subtopic. And under linear motion, we have distance covered. We still have a time taken, and still we have the speed used by the body and the motion. So those are some of the first three things that you have to know under linear motion. So once again, if you are given a distance between two points, let this be point A and this one be point B, then you are given a distance D, and you might be given speed, let's say speed K in kilometers per hour, let's say in kilometers per hour, but distance is in kilometers. So once again, to calculate time, you have to say time is equivalent to distance you divide by your speed. And once again, you have to know that if distance, you take distance divided by speed, you will get time. If you get distance divided by your time, you will get speed. And if you need to get the distance, you will take speed you multiply by the time taken by the body. So once again, what you have to check very well is to check what you are given. Like for example, you might be told that distance between 2 points is 200 kilometers, and a bus took 2 hours and maybe 30 minutes. So this one will be your distance, and you are told that time taken was 2 hours and 30 minutes, which means it's 2.5 hours. So once again, you may be asked what was the speed. So just say speed is given by distance, then you divide by time. Once again, you have to know that you will take your 200 kilometers, then you are dividing by, it is like 5/2. We change to improper fraction, which means it's just 200 multiplied by 2/5. So by 5 you are getting 40. So 40 times 2, you are getting it is 80. Then it is 8 kilometers per hour. So once again, your speed will be 80 kilometers per hour. So that's how you can calculate it for speed, given that distance, and you are given also time taken. Again, you might be given uh, time and maybe speed, and we are told to calculate it for your distance. Then so you are saying that distance is given by speed multiplied by time. And by just looking at this formula and the formula here, you are able to say that you can come up with one general formula that you can use to calculate all that by saying your distance. You are getting here, it is time. So you can just come up with this small triangle. It will help you very much when calculating for distance and the time. Um, Once again, uh, if you are to calculate or convert, there's now conversion. So convert kilometers per hour to meters per second. What do you normally check? What do you normally do? So once again, it is very simple. You just ask yourself, between a kilometer and a meter, which one is big? And you see that kilometer is big. So if you are converting kilometer to meter, then it means it will become more or less. So if you are given it the speed, let's just use the speed that we had here of 80 kilometers per hour, then you have to convert into meters per second. It means you will multiply by 1,000. Remember, it's 1,000 meters, which makes 1 kilometer, and it is 3600 seconds, which makes 1 hour. So if you are converting from kilometer per hour to meters per second, you'll multiply by 1,000 over 3600. So what you get, this one is just 5/18. So your final answer will be, so if you get 80 kilometers multiplied by 5, you are getting it is 400 divided by 18, and this one gives you 22 and 2/9 meters per seconds. So once again, you may be given to convert from meters per second to kilometers per hour. So what you normally do, it's very simple. You just take, maybe you are given it is 20 meters per second, then convert to kilometers per hour. Converting from meters to kilometers, then you are converting to a big number. So it means it will be more over less. So it will be 20 meters per second. You are multiplying by 3600 all over 1000, and this one gives you 2 times 36, which is 72 kilometers per hour. So once again, you have to be very keen when converting from kilometers per hour to meters per second, from meters per second to kilometers per hour. Another thing that you have to be very aware of is something we call relative speed. So let's just look at relative speed. Relative speed. So relative speed here, you have to look at the difference. If maybe we have two vehicles and they were from point A to point B, both of them, one vehicle was moving at speed of maybe 80 kilometers per hour, and it was moving toward B, and the other vehicle was moving at 100, let's say 100 kilometers per hour. We normally say that if you are converting the relative speed, if you are calculating for relative speed of two bodies moving in the same direction, then you just check for the difference. So it is 100 minus 80 kilometers, both are kilometers, and you are getting it is 20 kilometers. So once again, if it is that, you have to know that it is the difference between the speeds will be your relative speed. Assuming the two bodies were just to meet, one body is from B and the other one was from A. If this one was moving at 80 kilometers per hour towards B, and the other one was moving at 100 towards A, 100 kilometers per hour, then you say the relative speed is given by taking the sum. So the sum will be 100 plus 80, which is giving you 180. kilometers per hour. Then you can be given a question like this. The distance from Nairobi to Mombasa is 500 kilometers. A matatu left for Mombasa at 8 a.m. and traveled at average speed of 70 kilometers per hour. At 9 a.m., a car left Nairobi for Mombasa at an average speed of 100 kilometers per hour. Then the question may be, at what time did the car overtook the matatu? So this question is very simple. So the distance between Nairobi and Mombasa is 500 kilometers, and a matatu traveling at speed of 70 kilometers per hour left at 8 a.m. and at 9 a car left Nairobi for Mombasa at an average speed of 100 kilometers per hour. At what time did the car overtook the matatu? So first thing, what you have to calculate is the distance covered by bus, distance covered by the matatu before 9 a.m. So before the car left, what distance was already covered by the matatu? And you are getting, we've said that distance is given by speed multiplied by time, and speed was 70 kilometers per hour. Then you are multiplied by 1 hour, of which this and this will just go, so it has already traveled for 70 kilometers. Then you have to calculate for the relative speed of the two bodies. Remember, they were going on the same direction, and if they were going for the same direction, what you normally do, you take the difference. So relative speed will be equal to 100 minus 70, and you are getting this 30 kilometers per hour. Once again, what you normally do to know the time that the car overtook the matatu, then you will take the relative speed and you divide by the distance that the bus had already traveled. So we are saying time is given by distance over speed, and the distance was already 70 kilometers, and divided by relative speed, which means you are getting everything in hours. So it is 7, you are dividing by 3, and you get it is after 2 hours, because of 6 1, so it is 2 hours and a third, which means it's just 2 hours and 20 minutes. So at what time did the car overtook the bus? At what time did the car overtook the matatu? It means it is 9. Remember, it left at 9 a.m. Then you are adding 2 hours and some 20 minutes. So you are getting it is exactly at 11:20 a.m. At 11:20 a.m. This is the time that the car overtook the bus. Once again, you may be asked, at what distance did the car cover before overtaking the bus? Before overtaking the bus. So remember, it has just traveled for 2 hours and 20 minutes. This one is just the equivalent. It has just traveled for 2 hours and 20 minutes, and it was using a speed of 100 kilometers per hour. So distance will be 100. You are multiplying by 2 hours and 20 minutes, which is the same as 7 over 3 is the same as 7 over 3, which is 700 divided by 3, and you are getting it is 233 kilometers. So it covered 233 kilometers. You can also say that the bus had already covered 70 kilometers. Let's use second method. And the time that the car has used it to overtake the bus is 2 hours and that. So let's say it is 70 kilometers per hour that the bus was using. Then you are multiplying by time, which is the 7 over 3. Then you will add with the distance that the bus had already covered. And this one gives you 490. 490 divided by 3. So 490 divided by 3. You are getting it is just because of 1, 4 to get it's in by what? Let's drop this 9 here. So by 3 you are getting it's 9, then 0. Yeah, because of 19. So 3 by 6 because of 18. So let's subtract. You are getting it is what? It is 1. So 3 because of 9, and the 3 will just recurring. So 163.33 you are adding to 70, of which you are getting it is still 233.33. So you can just use the speed of the car multiplied by the time it has taken, and you still get this. All you multiply the speed of the bus with the time that the car took to overtake the bus, and you add with the initial distance that it had already covered. Once again, we can be given another sort of relative speed where maybe the two bodies were to meet. So one vehicle was from town A and the other vehicle was from town B. Then you are told that the distance between the two towns is 300 kilometers. What do you normally do to know that we've said that the relative speed of two vehicles that were to meet, if they were to meet, then you take the sum. You just take the sum, and once again, vehicle from town A was moving at 80 kilometers per hour, but vehicle from town B was moving at 60 kilometers per hour. So once again, if these vehicles they left at the same time from A and from B respectively, at what time did they meet? So once again, you have to take the relative speed. Relative speed will be 80 plus 60, which is 140 kilometers per hour. So time taken for the vehicle to meet will be the total distance divided by relative speed. That will give us the time that the vehicle met. So 300 divided by 140, so that over 14, which is basically 2 hours. So by 2, because of 28, 2, 0, 1, or let's just say it is 2 and 1 over 7, of which this we can convert into minutes. How get after 2 hours and 1 over 7 of 60, it is the time that they took to meet. So once again, you may be asked to calculate the distance that maybe this vehicle covered before meeting this other vehicle, and it will be the speed that it used, which is 8 kilometers per hour, multiplied by the time taken for them to meet, which is just it is like 15 over 7. 15 over 7. After multiplying this, what you'll get, it is the distance. Remember, this one is in hours. It is the distance that the this bus used before meeting the other vehicle. Inversely, you may be just asked to calculate the time that the vehicle from town B used to meet the other vehicle in town A, from town A. So once again, you just take the 60 kilometers per hour, which is the speed for the vehicle from town B. You multiply by the time taken for the two vehicles to meet, and this will just give you direct the distance that it had covered from this side. But in most cases, the questions are very technical. You may just be asked, what is the distance which is remaining by the time vehicle from town A and town B met? So this one needs you to just be very keen after calculating this distance that you'll get, or after calculating the distance that you'll get, you should also know which vehicle was from which direction, because you can get here, let's say for example, it is let's say 160. It had covered already 16 kilometers, and this one had covered 140 kilometers, but they have met. But the question may be, what is the distance that vehicle from town B was remaining to be in town A? So you just have this, then you subtract it from the original. But if you have used the other side, you just get this, and still you have the correct answer. So that is all that I can say about relative speed for two vehicles meeting, for two vehicles maybe were moving at the same direction. And you can just subscribe, like and share as I upload more.